Perfect. Very well. Here we have z equals to 1. Z equals to 1. This is your plane here. Z equals to 1. Then you have z equals to 5 on top. And you have x squared plus y squared equals to 4, which is your cylinder. The intersection between these two planes and your cylinder is this region here. So our goal is to identify this region, find the boundaries. Let's take a look at a better picture. There you go. So on top, you have z equals to 5. Down here, you have z equals to 1. And you're looking at this portion. What are we interested in? We're interested in the projection or shadow in XY plane. What is this shadow? What is this projection? Okay, let us just use this better visualization here. Skip this one a little bit. And there's that. Okay, perfect. So what is this shadow or the projection in XY plane? It seems like a circular region. Okay, let's get back to the region here. We know that z is bounded between 1 and 5. I don't have any problem with my z. I'm looking at x squared plus y squared less than equals to 4, which is giving me how we need to identify this shadow, this region down here. First of all, I'm going to use my cylindrical coordinates. Cylindrical coordinates. I know my z is bounded between 1 and 5. Okay, no problem there. Z is bounded between 1 and 1. Very good. If we use polar coordinates, we get x squared plus y squared less than equals to 4. What's the meaning of that? It means that if I just look at this shadow here, I'm trying to graph it using what we have here, so we have a better understanding of this shadow projection in XY plane. Here you have this region here. So my R bounded between 0 and 2. How about theta? My theta, okay, let's take a look at this. It starts from 0 and rotates 360 degrees, and my theta is in between 0 and 2 pi. So if I just practice, rotate this guy, so you have a better visualization. Two, minus 2, and minus 2. Now this is my y. And my theta ranges between 0 to 2 pi. Perfect. So Z is bounded between 1 and 5. R is bounded between 0 and 2. And theta is bounded between 0 to 2 pi. These are the boundaries for our shadow. So for shadow in xy plane, for our region projected in xy plane, and Z is bounded between 1 and 5. Perfect. So your integral, remember that here you have x squared plus y squared, and square root of x squared plus y squared is just r. And dv needs to be written as dz r, dr, d theta. So this triple integral can be written as, here we go. So my d theta, my outer integral is in between 0 to 2 pi, these are boundaries. And for dr, 0 to 2, 0 to 2, so this is your d theta, this is your dr. And how about your dz? Z ranges between 1 and, so dz, so there's your r here, and we have my dz here, and 1 to 5, there we go. And I have z times r. Remember that I have r times r gives you r squared. R is the radius. Your radius ranges between 0 and it goes to 2. This is your radius. Perfect. So since you have fixed boundaries, and here you have z times r squared, we can separate them. We can calculate each of these integrals separately and multiply the outcomes. So 0 to 2 pi for d theta times 0 to 2 r squared dr, and I have integral 1 to pi for my z dz. Very well. Yes, it's in polar coordinates. Very good. So the first integral, here you have theta bounded between 0 to 2 pi. The second one is a third, r cubed, r bounded between, so it starts from 0 and it stops at 2, and your z, here you have a half, z squared, 1, 2, 1. So this integral, which gave me theta ranges between 2 pi to 0. It is just 2 pi minus 0. And here I have a third times 8 minus 0 times, just multiply all of these, times a half. I have 25 minus 1. Okay, I get 2 pi times 8 over 3 times a half, 20. Okay, 64. Okay, guys, take your time.